y squared. You with me?
Yep.
Okay, cool. So here we need the derivative of x, the variables match, so there shouldn't be a problem. So what would it be? 1 times y squared, we're good. Plus x times the derivative of y squared with respect to x. Do the variables match?
No.
No. So get the derivative as normal.
2y.
What would it be with respect to y?
2y.
2y times the derivative of that y, which we're going to write what?
dy dx.
dy dx. Final answer here would be just y squared plus, put this guy's in order, put the 2 in the front, and then alphabetical order xy. And then
dy.
dy dx. What would we use to denote the derivative of y before? Like if I started off with y equals 5x, what would I say the derivative was? Y prime, right, equals 5? Okay, well y prime is another notation for what?
dy over dx.
dy over dx. Okay, just two different mathematicians that would use two different types of notation. One of them was Newton, the other one was Leibniz, right? And throughout the years, you know, we've kind of done what with their notations? Kind of mixed them up together, right? So here, if you wanted to use the y prime notation, you could. You could have said 2xy, y what? Y prime if you wanted to. I don't like to use that one because sometimes you mix it up and you think it's an exponent of a 1 rather than a prime. I like to use this one. Okay? Cool? Yeah? Alright. We okay? So let me write a little note over here for those of you that are still completely lost, just to kind of help you to know what you have to do. Whenever they ask you to find the derivative with respect to this box of whatever, you're going to check that the variables what? Match or do not match, right? Okay. When the variables do not match, okay, you have to find the derivative I guess as normal. So like if it's y squared, you get the derivative of y squared, you just put 2y. Okay? But don't forget and multiply by the derivative of the variable. So basically d whatever with respect to what it was originally with respect to. Kind of makes sense? Like right here, we got the derivative of 3y, we said that was what? 3, so we did it like normal. But then because the variables did not match, we had to say times what? dy over dx. Because we're saying we're getting the derivative of that y equation with respect to x. And we're assuming that that y equation, whatever it is defined to be, is something in terms of x. We don't know what it is, but we're assuming that it is. That's why we're doing it implicit. Kind of make sense? Sort of? It's a little weird. Just try to go with it, okay? Alright, let's look at some more examples. So this is basically going to restate everything that I just said. So let's just highlight the important parts in case you ever wanted to look back at it. Okay? So it says, explicit equations in x and y are such that y is isolated on one side of the equation and it equals an expression that is totally in terms of just x. Okay? So if you continue reading, it says, when I look at an explicitly defined equation, I can explicitly tell if it represents a function or not. Okay? So looking at this guy, would this guy be a function?
Yes.
Yes? How do you know?
Y equals
What does it say? I know that for every x there is only one y. How about this guy? Is this a function? Why not? For every x I'm gonna get two y's. I'm gonna get the positive one and the negative one, okay? So that's a big difference there, right? Implicit equations are very different, right? Typically, they do not have y isolated on one side of the equation, okay? And often there is a power on the y terms in the equation, and both y's and x's may appear throughout the equation. For example, this guy right here. X squared plus y squared minus 2x plus 4y plus 16 equals 0. Anybody know what that's the equation of? That is the equation of a circle. Man, you guys are good. How did you know that? Do you remember from pre-cal? Covered in pizza. Oh, it says right there. Yeah. Jeez, man, that gave it away. Okay, when you get to BC, okay, you're gonna start talking about other different types of equations, like equations of circles, equations of ellipses, equations of parabolas, not only opening up or down, but opening sideways, right? You're also gonna talk about hyperbolas, okay, not hyperboles like you do in English, but hyperbolas.
Geometry.
Like sideways.
No, you all don't even know what a hyperbole is?
Hyperbole, exaggeration.
Huh? It's an exaggeration? Awesome. Okay, good. This one, you know it's a circle because if you look at the x squared and y squared term, you notice that they have the same exact value and the same exact sign. So that's how you can tell it's a circle, right? Okay, if one of them were missing, if it only had an x squared or only had a y squared, we would know it was a parabola. Okay.
What is the negative 2x plus 4y plus 16?
Yeah, all of that, what it does is it causes it to move, right? So if we were to put it in a particular form, we would be able to know the circle's center, and we would also be able to know the circle's radius, and then we could be able to draw the circle. And we'll talk about that form of that equation in a little bit, just to refresh your memory from pre-con, or PSAT, wherever you saw it.
Wait, what?
Or maybe you have never seen it. No?
So it says right now.
It's okay, my child.
Wow.
Alright, so it says we will utilize an alternate notation for the derivative. Instead of f prime, since we're not going to be working with functions entirely, we're going to use what? dy dx. So anytime I ask you to find the derivative with respect to x, it's going to be dy over dx. Okay? As calculus was developed by two different men, a blend of their notation has been accepted. Okay, so like I said, it's a blend. Some of them use y prime, some of them use dy dx. We use both of them now. Cool? Alright, so let's find the derivatives both ways, implicitly and explicitly. Ready? Let's do this one. Y equals the square root of 25 minus x squared. Let's have a flashback. What would be this guy's derivative? Let's get the derivative of both sides. What would we use to represent the derivative of y? Y prime, but I don't want to use that anymore.
dy over dx.
dy over dx, okay, that was easy. Equals, what's the derivative of this side now? 1 half parentheses,
25 minus x squared.
25 minus x squared,
Parentheses negative 1 half.
to the negative 1 half power,
And then it's negative 2x.
negative 2x. Beautiful, chain rule. No trouble there? Then technically after this, it would be times dx dx, which would give me 1. That's why we would never put it. You understand? Yes? Yeah? You want me to put it or no?
No.
No? Okay. So what would cancel out here?
Everything.
The 2's, right? What would we end up with here? Negative x in the numerator and
2, no wait, radical.
square root of 25 minus x squared in the denominator. Is that easy? Not too bad? So it's always simple when the equations are explicit. It's even easier when they're implicit. You ready?
No.
Let's try this guy over here. So we have x squared plus y squared equals 25. Is that the equation of a circle?
maybe.
Yeah.
How do you know?
Because there's two.
X and Y's have the same values.
They both have squares. No, not only because they have squares, but
Same
because
value.
same exact value in the front. Okay. This guy over here is actually the radius
Yeah.
squared.
It's 5.
So the radius would actually be
5.
5. Very good. And the center of this circle would be at
0, 0.
0, 0, the origin. Cool, you guys awesome. You learned in PISA?
Yeah, no,
So proud of you.
I did not.
So let's get the derivative of this guy. Ready, Algerna? Alright, what's the derivative of x squared with respect to x?
2x.
2x, right? Okay, cool. Plus, what's the derivative of y squared with respect to x?
2y.
2y
Times dy over dx.
times dy dx. Very good. We get the derivative as normal with respect to that particular variable. You multiply by the implicit derivative. Equals, what's the derivative of 25?
0.
Anytime you're getting the derivative of an equation, you're always getting the derivative of both sides. Okay? Alright, so the last thing to do is to make it dy dx equals, because we ultimately want to know what the derivative is. So how could I do that? So minus the 2x. So we have 2y dy dx equals negative 2x. Okay, and then divide by 2y. So we found the derivative dy dx is equal to
X over Y.
X over y.
So what will this give me for that circle? What does the derivative tell me? What of the tangent lines? The slopes of the tangent lines at any point on that particular circle. If I drew a tangent line on it and I wanted to know its slope, this is the equation I would have to use.
So at 0 over 0, it would be undefined.
0, 0 would not be a point on this circle.
'Cause that's the
0,
center
0
of
would be the
triangle.
center of the circle. Yes?
I'm just kidding.
Cool? 0, 5 is a point, right? So if I went to 0, 5, what kind of a tan line would I have there on that circle? Horizontal, so the slope should be what? 0. So if I put 0 over 5, does that give me 0?
-0.
Yes. Beautiful? Okay, so that's where we have to use implicit differentiation. It's going to happen when we have equations that are not just your typical functions, okay? They're equations that, you know, are circles or ellipses or sidewards parabolas or all this weird stuff, okay? So this is really important. It's going to keep coming back over and over again for the rest of the year. So make sure you get it down. Just can't mess it up. So let's do a quick review of the circle stuff. I'm not going to spend an eternity on it. It's not a major thing. We'll just go through it real quickly. So looking at this guy, can anybody find the center of it? Because we need the equation.
Right there.
3, negative 2, man, you guys are good. How did you pick that out real quick?
We saw the lines and the eyes.
Huh?
We saw the lines.
You saw the lines?
Yeah.
So if that's the center, that means that this would be the diameter? Yeah? And then this would also be the diameter?
Yeah.
I have to do this all the time when I'm making barbecue pits and we're trying to cut out the covers for the sides of the barbecue pit. To try to find that center. It's pretty interesting. And then you have to like draw a circle with that particular radius, so that way you don't have to grind as much around the top. So that way you cut it perfectly, so when you add the weld, it just, you know, it's just perfect, you know?
Yeah, I agree.
Yeah?
Yeah,
Yeah, I mean, if you mess up, it's okay, right? You can just grind it off, right? You cut the circle a little bit too big. But then you're spending more money and wasting more time, right?
Why
Time
did
is
you buy a
money,
barbecue
right?
pit?
Anyway, so let's say you have
Gonna
like a
just
plasma
tell
cam and you can actually create a program and draw the circle to the right dimensions and it'll cut it out perfectly for you.
Gary the snail.
That would require more money, but it would make it the job more efficient, right? If you do it more. Yeah, you'd have to know some stuff, right?
do realize
You have to know like AutoCAD. No?
Tony knows.
I'm pretty sure those programs are more user friendly by now.
cylinder.
Have you done that? Have you used the one that I have at FFA? That cuts the design?
Yeah.
Is it easy?
You just like learn how to do like
It's not that bad? Awesome. Well, anyways, there's one application. Okay? Yeah? Alright. So, the center we said was at 3 what?
Negative.
3, negative 2. And what did we say the radius would be here? 5? How did you get that?
I
You just counted the squares. Yeah, that's a good idea. 1, 2, 3, 4, 5. The radius is 5. So if I went from here to here, it should also be 5?
Yes.
Yeah.
How about from here to here?
Anyway.
Yeah.
Up from there to there?
Everywhere.
Everywhere?
all the way.
Wow, isn't that amazing?
I guess so.
Yeah?
Like basically.
So would you say this circle has no corners or infinitely many corners?
Or when you draw it on the calculator.
I don't know, that was a question that was asked.
I think it has
Job
infinitely
bringers.
many corners. I know.
Interesting.
It's a matter of perspective.
Actually,
It's a matter of perspective.
no, it's a matter of fact. Wait, just kidding, I'm just kidding, I'm just kidding. No, you're not. That's what you said.
No, does anybody know the equation of a circle when you know the center?
Yeah.
What is it?